Protocols are a very widely used part of Python. In fact, you've probably worked with them in the standard library before and not even realized. They simply provide a way to say that a certain class should have either a certain set of attributes or a certain set of methods, or both. We've actually talked about protocols a little bit before in the descriptors video where I talked about the descriptor protocol, which indicated that descriptors must have a dunder-get, dunder-set, and dunder-delete method, or more accurately, at least one of those. While that example is a predefined protocol in Python, you can actually create your own using the typing.protocol class. And that is what I'm going to be showing off in this video. Quick little thing before we get into it though, if you are interested in seeing any of these videos earlier than anyone else, then consider becoming a member on the Carbarian tier using the join button below. With all that taken care of, let's learn how to design our own protocols. Python actually has a number of protocols built in already, as I alluded to in the introduction. And the first example I'm going to show you is actually how to essentially build one of those. So we are going to be building from typing import supports int. And this will check if a class has the dunder-int method attached to it. And if it does, then it can be converted to an integer, and as such it supports int. But if we were to do this ourselves, we would need the protocol, and then we would simply just do class supports int protocol, and then define this dunder-int here with the self, which is the signature that we would take. It then returns an integer as we would expect, and then we can use this ... syntax, or you can use parse if you want. But typically speaking, I've found that at least in PYI files, ... is used quite a lot to show, as it's essentially just a placeholder. So I'm just going to do it like that for this. And that's literally all it is. It is just a case of making a class inherit from protocol and then defining what attributes and methods, because you can put attributes on here as well, the class should support. And you can use these especially when it comes to type hinting. So if we do the def convert to int, and then we take just a value that supports an int, and then we can return an int. And now we can say that any value we pass in here will be convertible to an integer, at least as far as the type system is concerned. So if we were to do if name, not if annotations, if name double equals main, and then we did convert to int 1 or 1.0, integers and floats can both be converted to ints just fine, and as such, or they both specifically, they both define the dunder-int method. An int will literally just return itself, but a float will return a truncated version of it. If we were to do this again and then provide a list does not define the dunder-int method, as such cannot be converted to an int, and it will raise an error in the type system. However, if we try to do that in here, then it will get past that, and it will give us an error, but it will give us an error at the time it's converting, which we can actually prevent. So we could do if not is instance value supports int. We could do raise type error values not of instance supports int, and you'll notice we get an error if we do that, and that's because this protocol isn't runtime checkable, as they call it. So in order to make a protocol runtime checkable, you can import the decorator from typing and then just simply decorate the class with this runtime checkable. And what this does is essentially it allows you to use them in is-instance checks like this one. So now we can use this to check if value has a dunder-int at runtime, not just in the type system. And if it doesn't, we can raise an error much earlier and say type error. So instead of getting, well, we get a type error before, but now we get a different error, custom error here that says that a list is not an instance of class, and we probably want to do name actually in there. There we go. So or actually you could probably do cannot be converted to an integer. Whoopsie daisies, I've messed up. And now you get a bit of a custom error. So those are the basics of protocols. I do want to go over a few more examples to really kind of drill it in. And the first one we're going to do is sendable.py. And this one is going to, again, from typing import protocol. And then we're going to class sendable of a protocol. And we're going to have a method called send. And this is going to take a message of string. And then it's going to take an optional anonymous argument, which will default to false. And I just wanted to do this to show that it can take arguments and keyword arguments as much as you like. And then if I just copy paste the example, because it's not that spectacular, it just takes the object, takes the message, and then sends the message via the object. As you can see, we have this anonymous equals true. We can get rid of this, and now the behavior is changed, and then you have the same type-ins as before. I also want to use this example to talk about some limitations of protocols. So you can't have like partial protocols or protocols that accept arbitrary arguments. So you can sort of make it work at the actual function defining stage by doing something like quargs and then have that as any, and then do typing any. And then if we were to have a message, say, and it had a send argument, and we had that, and say that this message had an anonymous flag on it instead of the protocol itself. This would work as far as this is concerned. We don't get any problems with this yet. Even though anonymous isn't really recognized as an argument, that's fine so far. We're not getting any errors. If we were to try then and create this using send to and then message hello. So if we create a message, or maybe like a channel or something, not a message, that's probably better. So if we were to send to like a channel, and channel had this send, the protocol wouldn't match, because while the message is fine, anonymous and quargs don't really match up according to either MyPy or Pyrite. And there isn't really a way around this. There are some issues in GitHub. So there is if I just bring this over and then zoom this in a bit, we have this Pyrite one, which is the one I found first. How to write a protocol that has a method that accepts arbitrary arguments, with a similar example. And then the solution is largely just to, where is it? Essentially just to type hidden sort of nothing down here. And we have a similar one in MyPy. And the discussion was, or the consensus was pretty much that this shouldn't be fixed and that the type checkers are doing it properly. So that's just something to keep an eye out for with regard to protocols. So one final example I wanted to run over is how protocols can be useful to avoid having to import things all over the place and potentially avoiding circular imports when it comes to type checking. Of course, one way you can do it is by using the from typing import type checking, but protocols are another way you can do it. And I think quite a clean way of doing it, especially if a class is enormous or whatever. So let's say you have this setup app, and this is based off a real world example that I have, heavily changed to kind of anonymize it a bit. But you have this configuration, and then you have this app creation logic that accepts the configuration, but this is in a different file. And maybe it's in some like common library somewhere completely on the other end of the earth that doesn't have the ability to import config, or maybe there are circular imports for whatever reason. If we go into this create app here, we can see that we can define the config attributes that we need. You'll notice that we only need the service name and whether or not to configure malware when creating the app. So in a config situation, you're only going to need certain things in certain situations. In this case, we only need these two things. So we can create a protocol that ensures that our configuration has these two attributes on it. And if it does, then everything works fine. And that is also an example of how protocols can assert the the attributes are present on a class, as opposed to just methods. Of course, you can mix and match, so you can put both attributes and methods on the same protocol, make sure it has all of them. It's entirely up to you. Let me know in the comments if you've ever used protocols before. If you haven't, what you're planning to use them for now. And of course, if you have any questions about all this, then feel free to leave those down there as well. If you want to see all the other ways that Python is awesome, you can do so by visiting the Python is Awesome playlist. That will be linked on the end cards. And I'll see you next time for whatever we do next.